As biological beings, what we do is we collect light and then re-image that light using some sort of optical system, a lens like is in your eye or a telescope. That's certainly the simplest way to form an image, but it involves bulk optics for transporting the light and moving it around to form the image. And when the size of that aperture starts to get large, that completely dominates the sensor in terms of its size and weight and how much power it consumes. And there's a huge cost associated with that increase in size, weight, and power. SPIDER is a new way of collecting light to form images. So interferometry is just a way of doing that. It's a way of taking light that's collected at two different places and combining it directly, interfering it, and it forms what are called interference fringes. Much like, if you have two waves in a lake that are interfering with each other and overlapping and forming these standing waves that you might have seen. So we collect the light, couple it into this silicon chip, move it around and combine it in a way that we can measure it with just ordinary detectors like you would have in your cell phone camera. And then take all of that data that's collected by those detectors, process it in a computer, and form an image. It's just a simple disk, and the disk itself is just made of silicon chips, very thin chips. And so it only scales in 2 dimensions. To have the same performance as the telescope behind me would have to have the same diameter, 1 meter diameter, but the thickness would stay the same.
We do all the operations on the light in the circuit instead of bouncing back and forth between mirrors. So it's just a way to shrink everything into a much smaller and lighter package.
For the SPIDER program, we're partnering with the University of California at Davis. And we picked them to work with because they have the unique expertise in designing and fabricating these kinds of photonic integrated circuits.
By working with Lockheed Martin, we are excited to make photon integrated circuits that are more functional but more compact. Our first generation photon integrated circuit was about the size of this palm. Second generation photon integrated circuit is about the size of my fingernail. It has about the same number of devices and same amount of functionality. Now, the third generation photon integrated circuit will be utilizing what you see in my background. It will utilize the 3D printing technology with the photon integrated circuits being written with the laser inscription, so they can have even higher density laser waveguides on a very compact volume.
SPIDER could offer the ability to do things we simply can't do today. It could offer a lot of commercial, terrestrial, and defense applications as well. Anywhere there's an optical imaging system, there's the potential to take advantage of this technology. We're very excited about being involved in the beginning stages of a project like SPIDER that has the potential to completely revolutionize the way imaging systems are built in the future.
We're trying to do something exciting and something that can change the world, and I think this technology prompted by Lockheed Martin is going to change the world in the future.